Mapping forest types can help us monitor forest changes, assess forest health, plan conservation actions, and evaluate the impacts of human activities and natural disturbances on forests. One of the challenges of mapping forest types is to capture their complexity and variability in a realistic and accurate way. Traditional methods of mapping forests rely on 2D maps that do not account for the vertical dimension of forests, which is important for understanding their structure and function. In this video, I will show you how we can overcome these limitations by creating a 3D forest type map in R using a rayshader. With rayshader, we can transform our 2D maps into 3D models that can reveal the elevation, slope, aspect, and texture of the terrain. And one of the maps that's really caught my attention and inspired me to make this video is this map. So get ready, we'll be creating something very similar to this. All right, let's get started by, first of all, defining the packages that we want to install and then load into this R session. I'm going to call this list libs. And the first package that we'll need is geospatial for fetching national boundaries in the SF format. The second one is Terra, because in this tutorial we'll be working a lot with raster files, well, at least two raster files. The one is the forest type raster and the other one is the terrain configuration. So for the terrain elevation, we will need elevator package, which is going to help us fetch them in no time. The next one is the PNG package, which is going to help us turn the forest type raster into an image so that we can then use it as an overlay in rayshader. And the rayshader itself is going to help us render a scene and then also render a high quality object. And the final one is the magic package, which we will use to put together the 3D map and also the appropriate legend. All right, once we have this list, we first of all need to check if the packages from this list are in install packages in our library. So what we're going to do here is we're going to go and search within the row names of installed packages. All right, and then once we determine what are the packages that are installed, the next thing is we actually need to install those packages that are not there. So here we need to write an if-else statement. So if there are no some of the members from that list among these install libs, then we need to tell R to install packages, but not all packages. We want to install libs and also those members of the libs that are not among the install libs. And the final step is, of course, to load the packages that we installed. And for that purpose, we can use the library function. Library function is used in R to load packages. So in this case, we're going to apply this library package or library function to our libs list. In this tutorial, we'll be creating a 3D forest type map of Slovenia. So the first thing we need to do is fetch the boundaries of Slovenia in the SF format so that later on we can crop all those raster files using the Slovenian borders. So I'm going to create here a generic name called country SF. One thing to notice here, it doesn't need to be a country. It can be any other, of course, geo object which is in the form of a shapefile. So it can be also region, municipality, anything else you can imagine. So for now, we're going to be using geospatial and we're going to get the national boundaries of Slovenia using geospatial get countries. So once we actually have this, we need to define the country in the form of the ISO2 code. For Slovenia, that's SI. And then we also can define on the resolution, so how crisp this is, how detailed this is going to be. So I'm taking this one, which means the most detailed. In today's tutorial, we'll be working with forest types, and I'm really glad to be back to the Copernicus land cover website, which we used in one of the previous tutorials where we mapped forest fractional covers and created also a rayshader map. So over here, what we have on the left-hand side is a dataset that we've been using. If you click on all forest types in this menu on land cover classification, a new colors will open up here and showing you a new palette. And there's also going to be a new legend in the lower right corner where you will see 6 types of forests that can appear on this map. Of course, this one is coupled with the land cover, but once we download the data, it's going to be only and only for the forest types. So there are 6 forest types. And how do I know that? Well, I know that if I go on a download button here, click on it, and then I click on this product user manual, it's gonna open a new window where you can scroll through this codebook. Well, while we are not interested in the entire codebook, we are definitely interested in something which is called forest type layer. So forest type layer is on page 29. So if we go now to page 29, we will see what the values are here. Okay, so it says forest type layer provides discrete values per type of forests, and the value, which is the missing value, is 255. So this is very important to remember. And then, as I said, there are 6 values here. So 0 is unknown, so it doesn't match any of other types. Then we have evergreen needle-leaf forests, which is 1. 2 is also evergreen but broadleaf forest. 3 and 4 are deciduous, needle and broadleaf, and finally 5 is a mixed type of forest. Okay, going back to the download screen, because this is what we need. Here, what we want to do is we want to download the file for Slovenia. We'll be working with Slovenia. We're going to be creating a map of forest types for Slovenia. So if you go back to one of my previous tutorials where I discuss how to download this, there's also a nice cheat sheet which will help you directly find the link here and how to make it. But in this case, we just need a link to this single raster file. So we're just going to be clicking here, and this will open a new window. And then you remember in that last tutorial where we used this Copernicus global land cover, we were actually downloading forests, but this time we're going to be downloading forest types. So you need to click here on forest types in this menu, and we need the most recent data, which is 2019. So what you can do is you can either click here, which is going to initiate a download, or you can go and copy this link to this file. So I'm going to copy the link to this file, and the next thing is I'm going to use R to download this file directly on my local drive and then work onwards in R. If you decided to download the file directly through R, I pasted here the link. So what we will do next is wrap the quotation marks around this link and then pass it to the object, which we're going to call URL. And then to downloads, we're going to use download.file from base R. Here we need to define the URL, which is also called URL. Then we need to define the name of the destination file. So here we can simply grab the file base name from this link. And finally, we should also take here a binary mode for downloading. All right, once you downloaded the file, you can also load it. We can use Terra for that. So we're going to call this object forest type. And then from Terra, we're going to specifically use a Rust function. And here we can simply use this base name URL. So this is also going to load then this raster file. And once we do that, we can then inspect what actually is here. You know, what is this forest type? How does this look like? So let's quickly do that. Because I do want to show you what actually this one has. So here we can see the dimensions, we can see the resolution, we can see the coordinates reference system is WGS84, and we can also see that the minimum value is 0 and the maximum value is 5. So you remember from that codebook what that actually means. But the thing is, we don't really know if all the values are also present in this fragment, in this specific raster. So this is the next thing that we're going to check out. Checking the values of raster files is pretty straightforward with Terra. What we need to do is we need to use a values function from Terra. And over here, we simply need to pass the name of our raster file, which is forest type, and then also the form that we want to result to be returned in. So we're going to use here a data frame. And once we do that, we can we could inspect quickly, but what I want to show you actually, there's only one column. And this column is actually called, there is a very strange name to it, which actually simply reflects the name of this layer. So this is it. So it's name of the file actually that is here. So what we want to do quickly, simply just change this first and only name and just put something which makes more sense, which is, let's just call it value. And once we do that, we can then actually check what are the unique values in our data. So in this vals data frame, what are the unique values? and I'm just gonna quickly pull this up so that you can see what are the unique values. And the unique values, as you can see, so we don't have all the values. So we have NA values for those places that don't have forests, maybe they have lakes or rivers. So we have then 0, 1, 5, and 4. So this is a very important part. So we don't have 2 and 3. And this is also going to now shape our decisions when it comes to also encoding these values, but also showing them on the legend, but also in the map. Since we are mapping a European country, then we'll be using a Lambert projection here. And this is the projection and how it looks like. But first things first, we do want to actually crop this forest type by the Slovenian boundaries in order to get the forest type raster only for Slovenia. So this is how we're going to do that. I'm going to call this country forest type. And then from Terra, I'm going to be using crop function. For crop function, first thing you need to provide is the raster file. The second one is the vector file. So country SF. And to make sure that this actually goes smoothly, we will coerce this SF object into a vector format. And then here, what we're going to say is that we're going to only take what is inside of the boundaries. So basically the Slovenian raster, and then the rest we're just going to mask. And then the final step is to reproject this raster. For that, we will be using the project function from Terra. And here we can simply pass this CRS_Lambert. And now once we are done with this, we can also plot and see whether we actually succeeded at what we planned. So after we run this Terra plots applied to this country forest type, you should be able to see this Terra plots with this very vivid colors representing the forest type of Slovenia. Those are very cool colors, but we're gonna go with a different palette, which I actually defined here. But more than that, I'm gonna assign this palette to our specific raster values in a certain order. And after that, I'm gonna turn this raster into an image file in specific PNG. I'm doing that because this is the only way for us to use this as an overlay in rayshader when creating a 3D map. Otherwise, we wouldn't be able to do that. So here are the steps. First of all, I define these colors as a list. Second thing, we will need to use both these colors and also the values from the raster file, and then create this unique palette which we're going to assign to its values. So first of all, these are the colors. Second, we need to define the values from two values. So first of all, from values. Our values here, if you remember, are 0 to 1. So we are kind of excluding here NA values. We're not going to assign any color to them. So as we said, 0, 1, 4, 5. Okay, and then the second one is to define what are you going to do? How are you going to turn these values into specific color palette? Okay, so for that one, we need to use function from base R, which is called call to RGB, or basically to translate this to you, color to red, green, and blue colors. And for that, we're going to use calls that we already defined. Okay, so we have these parameters. Next thing is actually the next thing is, first of all, get rid of those, NA values. So we're gonna, for example, create here an object called forest Terra. And then we can simply use here NA omit. And we're gonna omit from this country forest type. Okay, so that's the next thing. And then the final thing is to actually create a new raster object where we will substitute the color values that are currently exist using, of course, these numeric values that already exist. So we're gonna assign specific colors to those numeric values in the raster file. Okay, so we can then just call this forest type image, and then to assign specific color values to your existing numeric values, you need to use subst function from Terra. So then we will apply this to this forest Terra, which doesn't have any values, and then we're going to have from arguments, to arguments, and then for the names we will use the colors. So this is how we're going to assign that. And once this is done, we can actually check if these changes are really correct, if we actually really managed to assign those color palettes. So we can use Terra for that. We can use Terra and we can plot actually this RGB using plots and then RGB. And then we're going to just plot this forest type image. Actually, maybe forest type image is not the appropriate name here because this is still a raster, but you know what I'm hitting at. It could maybe be RGB, but it doesn't matter. So if you actually run this and plot, you should be able to see an image like this. And it seems that we actually got the patterns and we definitely got the colors where we wanted them to be. And then the last step is to simply turn this raster into an image file. So first of all, we're gonna come up with some image file name. Let's call it, for example, Slovenia forests image.png. And then we need to save this file locally as a PNG. So for that, we can use Terabyte raster. So you can use Terabyte raster not simply for raster, but you can see also for image files. So here we want to save this forest type image. Then we want to assign it this image file. Of course, if you already have something under the same name, it's better to use this overwrite equals true, which will then is going to overwrite. And then one thing that if you remember from the codebook, the NA values were 255. We actually need to tell Terra here that the NA values are equal to 255. So that argument is called NA flag, and we can simply pass this as a numeric argument. Okay, and then once we run this whole thing, this is going to save it to our local drive as a PNG file. And the last step is to simply load this PNG file. So we can just call it img. And for loading, we need to use the PNG package and read PNG function. And then here we can simply pass this image file name, just like this. And the last step before we can render the scene and also our 3D map is to fetch the elevation raster for Slovenia. So we're going to create an object called elev, and we're going to use elevator package and get elev raster function for getting, of course, for the country. So locations is the argument here. We're going to pass country SF to locations because we want only for Slovenia. Then we choose the level of detail, which can range from 1 to more. I'm going to go for 10 because Slovenia is a small country, so I want a high level of detail. But if you are working with some greater area, region, or country, you should consider decreasing this value. And then the final thing is how I want to clip this. You can also clip by the bounding box of the country, but here I'm just going to clip by the locations themselves. Okay, and we also need to make sure that this elevation raster has the same coordinates reference system as our another forest type raster or forest type image, so to say. So for that purpose, we need to coerce this one into a Lambert projection. So what I'm going to do here is simply create a new object. I'm going to call it elev Lambert. And then here, first of all, this object that we just fetched comes as a raster object. We want it to be a Terra object. So I'm just going to coerce it here into Terra. So it's just the difference between two libraries. That's the one thing. And the second thing, we will reproject. Once more, we'll be using the project function from Terra. And as we do that, we are actually ready to prepare this for ray shadering. So I'm going to create here a matrix because ray shader works with matrices. So I'm going to call this matrix LMAT. And then from ray shader itself, I will be using here raster to matrix function, which is very convenient, helps us do that. And then I'm just going to pass here this elev Lambert. And we are ready to render our scene, but first things first, let's define the width and the height of our scene using information from the elevation raster. So I'm going to create here two objects. The first one is going to be called H, and it's going to capture the number of rows from this elev Lambert. And the second one is going to be called W, standing for width, and it's going to count the number of columns also in this elev Lambert. Okay, now we can build actually the query itself. So we're going to start off from element. That's going to be our base. And then here, the first thing is to define the actual height shade. So what is going to be this base layer, how it's going to look like. So rayshader, height shade. And remember, the base layer for us is going to be the elevation. So here we need to define the texture. And here, what I would like to do is I'm just gonna pass here white color. And I'm gonna actually create here color ramp palette, which is used for creating, different color palettes. And I'm just gonna pass here white. And here you can pass any number of values you actually want. So this is what I wanna make sure. That's the first thing. The second thing is to add an overlay to this. So that's quite easy. We can just use rayshader and then add overlay arguments. And then within this one, we will pass this image that we previously created and then load it as a PNG file into R. Then what you can do here is you can determine how transparent your layer is going to be. So I don't want this image with the colors to be that transparent. So if you don't want it to be transparent, or if you want it to be completely visible, then the value of 1 is the way to go. If you want it to be completely transparent, then the value of 0 is the way to go. Of course, I don't want the colors completely to dominate the landscape. I do also want to see, those hue shades. So for that purpose, I'm not going to go with 1. I'm going to go, for example, with 0.9. But I think you can definitely experiment with this one. Okay, and then a very important step here is I would like alpha color to actually be white. So for everything that's, in other words, that doesn't have assigned value, I'm just going to turn it into white, which is then going to correspond with, surprise, surprise, with this hue shade. So that's perfect. That's what we need. Okay, there are some additional options here that I want to show you, some additional tricks which you don't need to consider, and they are related to actually setting options for the shadow that you want to use. So this is gonna add a bit of a more flavor to the map. It's gonna make it more 3D, so to say. This is what shadows are for, combined with, of course, light. So here I would like to add ambient shadow, which is gonna make the scene a bit softer, so to say. So lamp shadow. And here we, of course, need to pass this main elevation matrix. That's the thing. Then we need to define several things. First of all, how high this shadow is going to be. So the higher Z scale here you take, the shadow is not going to be, that high. So it's going to be smaller. And I'm going to go here for, let's say, 50. So the smaller value you take, it's going to be much longer. And I think that kind of does not bode well with the scene, because then those spikes that you want to show, they are kind of overwhelmed with a lot of shadows behind them. You can also, for example, choose here sun altitude. It can be, for example, 90 degrees, so it means the source of light is coming directly onto the scene, so that's sun altitude. You can also, for example, choose sun angle, and I think 315 is anyways the default one. So these are some of the options that you can choose, and what you can also choose is how dark are going to be those, shadow things. So here I'm going to go, maybe surprising, for something that is a bit darker. So darker values here are associated with lower values. So between 0 and 1, 0 would be darker and 1 would be light. So I do want it to be a bit darker so that we see also this shadow effect, which is gonna also help us create a nice 3D effect overall. So that's one thing, which is the ambient shadow, but there is also a so-called texture shadow. So it's also handled by this rayshader add shadow part. And what this is for is to so texture shadow actually add lines along certain parts of the plots, depending, of course, on the values of itself. So for elevation, those would be kind of a contour lines, so to say. And then they also accentuate certain features of the plot itself. So that's also pretty cool. So again, we can call here rayshader, and then this one is called texture shadow. Or texture shade, actually. Okay, and then we can open here. And then there are several things, again, that we need to define. So first one is this elevation matrix. Second one, though, is the level of detail. So how complex this shadow is going to be. And here, I'm going to go for something which is very computational intensive, so a higher level of detail. which is closer to 1. If you choose something that is closer to 0 means less detail. And also or in contrast to this one, here you can also choose, for example, your level of brightness. So level of brightness, the more you increase above 0, the brighter it is. So we're going to go for, let's say, for example, 90. And you can also set the contrast. And contrast, again, the higher it is, the stronger it is, the brighter it is also. So I'm going to go for 80 contrast here. And again, you can also darken or lighten those lines of these shadows. And here I'm also going to go for something a bit darker here, again, to accentuate specific features of the plot, so make it more detailed. Okay, but these two parts about the shadows, they're completely optional, so you don't need to go for that if you don't feel like it. And you can immediately go to plot 3D, which we're going to do next. So plot 3D is the next option. So in this one, we again need to define, of course, the elevation matrix. That's the main one. Then you want to define also how high those spikes are going to be. Again, we're going to use as a scale. One value means they're very, very high, very tall spikes. I'm going to go for something like, for example, 5. Several other things. I'm going to get rid of any kind of a plane around the map itself. So I'm going to put solid to false. Shadows are going to be there because we already set options for shadows. Shadow darkness is how dark the shadows are going to be. So shadow darkness. And here, if you want shadows not to be that dark, you can go for 1, which is the maximum value. If you want shadows to be very dark, you will go for 0. Or you can go from somewhere in between, which is the default value. You can also set, if you want, background color, for example, white, or some other color. And also here you can set, for example, the size of your window. So what I do like to do here is use those dimensions that we already defined. But because here we are working with pixels, I am going to decrease a bit pixels here. So I'm going to decrease 5 times. What is very important here is the order of appearance. So first width and then height. And second thing, if you are dividing width by 5, you should have the same ratio for height and vice versa. So apart from these things, you can also define zoom. So if you want to zoom in completely, then you would use the value, let's say, of 0. If you want to zoom out completely, that's the value of 1. I'm just going to go for something in between 0.5. And you can also choose the angle of the scene. I'm going to go for 85 degrees. So yeah, in this case, those spikes are not going to be that pronounced. And finally, you can also tilt if you want the scene. I don't prefer tilting, so I'm just going to keep here at 0. So these are some of the things that you can do and that you can specify here. But the most important ones are definitely defining here the height shade and also the texture that you're going to use, defining the overlay, and how transparent the overlay is going to be. These two are about shadows, which are optional. And then the final one is definitely mandatory because this is about actually rendering the scene itself. So if you followed everything closely so far and you finally run this code, you should be able to see the render scene, which looks something like this. So pretty similar to what we have. The only difference being that now there are some shadows, of course, depending on the hue shade, but the next step is going to be very exciting, which is rendering the scene using render high quality. Okay, and the final step is to render the object itself and then also to save it locally. So once again, we're calling to rescue rayshader and its function called render high quality. So here, first things first, we need to define what is going to be the name of that file that we're going to create. So let's say, for example, forest type Slovenia 3D.png. The second thing is we do want to track what's going on. So I'm going to enable here the preview of the rendering itself. Now, the third thing, this is something new. So I'm going to actually turn off the lights, but you might be wondering, isn't this going to create the dark? Yes, there's going to be darkness unless you actually load a specific file with already rendered light scene. That's right. So there is a website where you can download sorts of different free and free for use, not just for non-commercial, but also commercial purposes, different HDR objects with different render lights which you can apply to the scene, and I found one of them which is called Air Museum Playground 4K, and I downloaded it to my local drive, and I put it actually in the same folder where I put where actually I'm working here. So it's my working directory. So this is what you should also do. And now I'm actually going to call it within rayshader. So here we need to define, first of all, this environment light. And also one more thing, if you're interested in these lights, I'm going to also provide the link to this website where I found these different light files in the description box below. So do check it out if you're interested in trying out maybe some other types of lights that people created. So, but for now, I'm just going to create here environment lights, and of course, I'm going to call it by the name of that one that I downloaded. So it's called Air Museum Playgrounds 4K, and it needs to be HDR. So once again, you need to make sure that this file that you downloaded is in the same place as your main working directory currently. That's very important. Otherwise, you know, rayshader is not going to know what you provided. It's not going to find the file. Okay, so that's one thing. So there are two more very cool features that you can pass to rayshader, and one of them is, for example, you can intensify the light here. So you don't need to accept what is currently there. You can make it lighter or you can make it darker. In order to make it lighter, you need to choose the values which are higher than 0. So first of all, you need to write here intensity E and V. So that's the arguments that you can use for changing. And here I'm gonna use a much higher light. So I'm gonna pass value of 2. You can also check what happens if you take higher or lower values. And the second cool thing when you are working with this lights that you pass to rayshader is that you can also rotate the light. So in this one, in this concrete one, the light is not coming from the way that I want. The way that I want from a light to be, I would like it to be coming from southwest. So here I need to rotate by 90 degrees to get that. So for that reason, I'm going to use here this rotate underscore also env, and I'm going to pass here 90 degrees. Okay, and then there are a few other stuff here. So for example, I'm going to turn off the interactive option, which basically allows you to move the object as it renders, which I find scary because it can actually lead to our crashing. But I do want to use here parallel option, so I'm gonna enable it because then it's going to also maximize my computer resources. And finally, you can also define the width and the height, and here I'm just gonna pass the width and height that we defined since they are already pretty high values. Once you're done with rendering, you should be able to see image that looks like this. It looks pretty crisp. There are all the colors around, but the most important thing is that there is also the elevation, which gives it a 3D effect. It looks very nice, but there is one thing that is missing from this picture, which is the legend. So we are not really sure what these colors mean. And in this part, we're gonna be making a legend. So what we're going to do is a bit of a tweak here. We're going to create a plot using base R, and then we're going to grab, this plot is actually going to be just a legend. It's going to have the color values we have, it's going to have the appropriate legend labels, and then we're going to save this basically legend plots as a PNG locally, and then we're going to bring it into R again together with that rendered image name, and then put them together, and then we'll have a final plot. But first things first, let's first of all create this legend plot, and we're going to be using here base R. So the first thing to do in base R is to define what is going to be the device that you're going to use to save. So we're going to be creating a PNG object, so we're going to be using PNG device, and to also define your the name of your file. So I'm going to call this mylegend.png. The second thing, which is not necessary, is to define some of the global parameters for this object, but I do want to use the mono font family, so I'm going to define it. The third thing is finally to make a plot. Now the thing is here, we don't care about any plot, we just want to create a legend. So for that reason, the plot here is going to be null. And then we want, or I do want, to create this legend so that it has circles. So in base R, there's several things here that you need to define as a circle, and to define it as a circle, you use simply M. So for each of these dimensions, for each of the Y and X axes that a plot can have, you need to put here that it's going to be in a round format. That's very important because otherwise this is simply going to have a different shape, which is totally fine. One thing you should also do here is make sure that your Y-axis and X-axis labs are also empty. So this is how you're going to do it. You're just going to provide here for Y lab and X lab just these empty strings. And then what you also want to do is you want to shrink the limits around your X and Y axis. And to make it as small as possible, you can just take values from 0 to 1 for this X limits, and you can do the same also for these Y limits. Okay, and then the final one is to also decrease the white space. In the base R, you need to use this argument for both axes and pass I as the value. So Y, S, and then also I as the value. Okay, so this is the thing. As you can notice, in contrast to ggplot2, we're not adding any plus here. We're just writing one chunk of code after another. But in base R, this will execute the whole thing. And the next thing is actually the main thing, which we're here for, which is creating a legend. So to create a legend without the plots, which is null, we then provide within this legend parameter several things. First of all, where the legend is going to be, I want to put it into the center. Apparently, I wouldn't do this if I had a plot, but because we don't have a plot, I do like it to be centered nicely. Then we need to provide legend keys. And the way to do that is simply using legend arguments. So we want here labels. As we know, it starts from unknown. If we consult again that, of course, that codebook. So it starts from unknown. The second one is evergreen needle leaf. The third one, of course, I'm following only those values that we have. So it's not like 0 to 5. So these are 0, 1, 4, and 5. So this is now 0, 1. We're now at 4, which is Shidius broad leaf. And then, actually, I think I'm missing here U. And then the final one is mixed. So those are the types of legend values. And basically, this is pretty much the main thing. What we can also choose here is, for example, the shape, of course, of the legend. So 16 means that it's going to be a solid circle. There are other things that you can, for example, set here. One of them is, of course, the point, how big it's going to be. You know, we can, for example, go for 3. I think it's reasonable. If you want actually a larger, let's say, point, you can choose something that is greater than 3. If you want smaller, also something smaller than 3. And of course, one more thing here is that we want to also set the type that this is a point. And the final one is for colors. The colors need to be calls here. So this is also a very important part. And once you're actually done with this, you don't want to do anything else. You can simply use web off to close off the whole thing, which is then going to save locally the file. And once you actually save this, you should be able to see a legend that looks like this. And this is where the magic starts using the magic package. We will need to first of all load both of these images. So both the legend that we just created, but also that 3D map object. So let's start off by, first of all, loading forest image. So the way you actually load using magic is using image read function. So here I do need to see what is the name because I did forget the name. So it's okay. Forest type Slovenia 3D PNG. So that's the one that I used. So that's the first thing. And the second thing is the legend. So I'm gonna call this my legend again. And yeah, we're just going to be using the same command. So why not just copy it? And because it's also called my legend and it's also PNG, I can also use this. All right, so once we loaded this, the second thing we need to do is we need to scale a bit these images. In particular, we need to scale this legend object so it becomes actually smaller, so it does not go over the whole scene. So that's the second thing, and I'm going to call this new object my legend scales. Okay, so first of all here, using magic, we'll be using here image scale option. So image scale, and open this brackets. So then here, what I would like to have is, I would like to have image also backgrounds. So let's first of all deal with this. So first, my legends, this is what we're gonna scale. And we're gonna scale this to 2000 pixels. I mean, remember that we actually just now rendered an object that is, I think, 7 by 8000 or something like that. It's a very big one. So if you want this legend to be crisp and visible, we should also increase this. Okay, but one thing that I also want to make sure, as I just mentioned a moment ago, is I would like this to be background to be transparent, so that even if the legend plot goes over the map, it does not really affect it. So I want to make this legend transparent, and for that I'm going to be using image backgrounds. So you notice here that I'm passing to this same thing. I'm passing to it, and I'm going to say here that I want this image to be background to be none. In other words, I want it to be transparent. So everything else remains the same. Okay. And then the last thing here is to also define what it means to be transparent. So I'm going to use magic, and I'm going to do here image transparent, and I'm going to turn it into white so that it actually also fits well with the background. Okay, so once we define this, once we scale the legend, we can finally put them together. And for that, I'm going to here just create an object, which is going to be called P. It can be called whatever. I'm going to call magic. And to put together, you need to use option called image composite. So here, we need to also scale that forest image, and I would like it to be crisp. So I'm going to go with image scale. Of course, I'm still using magic here. Image scale. And then what do I want to scale? Well, I want to scale that forest image. And how many times I want to increase it? You will be shocked, but I'm going to increase it by 4000 times. And this is how you actually do it. So you need to provide here X and then that value. But don't be shocked, because I do want it to be very, very crisp. So this is what it's gonna take. So this is the first one. I scaled it, and then I'm gonna add to this forest image the one that I already scaled, and I called my legend scale. So I'm just gonna copy, put it here. And then the last thing is I'm gonna offset this legend scale, and I wanna put it to somewhere like northwest or north from the map. So for that, I'm going to use offset here, option. And then in the offset, I'm going to define here values. So values from the X and the Y axis. Okay, so this is going to be offset by 100 and then 0. Okay, so once this is done, we finally are ready to save this image. And we're going to use that image right. So first of all, the object that we want to save. And second one is the name. So let's call it, for example, finalmap.png. And once you run this whole thing related to the final map, from loading to scaling, putting together and then writing the final map, you should be finally able to see not just our beautiful 3D forest type map, but also now we have the legend, which clearly show us what these values mean. All right, that's all for today, folks. In today's tutorial, you learned how to create crisp forest type maps using both the elevation raster, but also the forest type raster. You also learned how to add overlay to rayshader and to create a custom legend. In today's tutorial, we created one such map of Slovenia, but I'm really excited how you take this tutorial on a journey across the world and create your own crisp forest type maps. If, however, you are interested in replicating today's analysis, I prepared a code in the GitHub repo, and the link is provided in the description box below. If you have any comments, questions, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your data visualization and geospatial knowledge with R, I prepared a few very useful tutorials for you, so go out and check them out. See you next time.